Okay, so part 2 is to find the value of a function. Okay, if we're finding the value of a function, you should think, oh, I must be plugging something in, right? How many of you remember the function machine from Algebra 1? Most teachers usually show the function machine as an example of I'm inputting something, it's gonna do some little math, and it's gonna pop out an output, right? That's what the function machine does, okay? It only accepts numbers from the domain of that function. So only numbers that will make it true go into the function machine. Okay, now I'm going to tell you that I did not give you a lot of room on here. I'm on a mission to only give you one piece of paper. And so this would be a good time to use page 1 in your notebook because you may need that extra space if you write largely. Okay. And so you're probably like, how would I put my paper here? Flip it up. Okay. Be creative. All right. So we're going to start with letter A, and letter A says we are evaluating the function negative 3x squared plus 2x at f of 3, right? And what is f of 3 tells me I'm doing? I'm going to substitute in for x, right? So wherever x is, it now becomes a 3. So we have negative 3, that's not a squared, plus 2 times 3. Okay. After I've substituted in, I'm now going to use what process to evaluate? PEMDAS. The order of operations. Please excuse my dear Aunt Sally. Okay. PEMDAS tells me I deal with my parentheses. Well, parentheses in this situation just mean multiply. So I deal with my exponent, then I multiply, then I add or subtract, correct? So here we have 3 squared. So that gives us negative 3 times 9 plus 6. What is negative 3 times 9? What is negative 27 plus 6? Negative 21. So our output for f of 3 is negative 21. Okay. Example A is a straightforward function notation with evaluating, right? Do we all feel comfortable being able to do example A? Okay. Now we're going to look at it with, well, what if I'm also using my original function? What if I'm also substituting in? So here we have f of x plus f of 3. So f of x plus f of 3 is basically double substitution. Well, what is f of x? Well, f of x is negative 3x squared plus 2x. Now, it says plus f of 3. Well, do we know what f of 3 is? Negative 21. So where it says plus f of 3, I'm just going to write negative 21. I asked myself, are there any like terms to be combined? And what does myself tell me? No. So guess what that means? Leave it. There are no like terms to be combined. So therefore I am done. A box. It happened. Okay. All right. Cool. Right. What's the difference between A and C? My 3 is different, right? This time my 3 is a coefficient. My 3 isn't the value I'm substituting in, it's the value that I'm multiplying everything by, each term by. Does that make sense? So for this one, we have 3 f of x. So this means I have 3 parentheses, negative 3x squared plus 2x, close parenthesis. How do I evaluate this? Distribute. And distribute just means I am doing what? Multiplying. You get a 3. You get a 3. We all get 3s. Okay. I call it the Oprah property. What is 3 times negative 3? What is 3 times 2? And guess what? We do it. Okay. How do we feel about having a coefficient outside of our function?
Great.
Doable?
Very.
All right. Next, this time we have D with the example of f of negative x. So f of negative x just means I'm doing what to all my x values? Making them negative. So if I have f of negative x, all of my x values are going to become a negative. So we have -3, negative x squared plus 2 times negative x. Well, what happens when you square a negative? It goes away because a negative times a negative makes a positive. So this right here, because of this square, it doesn't matter. It's just going to be still positive x. Okay. And this is where we will stop and resume manana.
You made me remember why I don't like this stuff. I hate it. I love you.